Okay, next, let's talk about something that you may or may not be familiar with, and that is the concept of blockchain. So, blockchain is an immutable, decentralized digital ledger that is distributed among a network of many computers, basically a peer to peer network. Once a transaction is recorded in this ledger, it can't be altered or removed, or at least not very easily. It's extremely tamper resistant. So, this provides trust, transparency, and near real time processing of transactions. So, a block is a batch of transactions with a cryptographic hash of the prior block, a timestamp, and some other information. So, that digital hash, as we'll learn in just a second, links these blocks together or makes a block chain. So, editing or altering a block would change all of the blocks that follow it. All right, and I'll talk about that more in just a moment. So here we have a visual representation of the blockchain. And you can think of it as a digital ledger, much like a checkbook would be in a checking account, right? It is a ledger of all transactions. Everything that gets done gets entered line by line into that ledger. Blockchain was actually initially conceived way back in 1991 as a timestamp for digital transactions. However, it didn't really gain any recognition or acceptance until it was adopted in 2009 by Satoshi Nakamoto. And I have his name highlighted here because we don't really know if he's a real person, if it's a pseudonym or a group of people. No one seems to know for sure. But it was developed by Satoshi Nakamoto for use with Bitcoin. So everyone is familiar with Bitcoin, cryptocurrency, and sometimes folks will commingle those terms and think that blockchain is Bitcoin or cryptocurrency. They're two distinct things. Bitcoin and cryptocurrency utilize the underlying technology of blockchain, but they're not exactly the same thing. Blockchain can exist outside of cryptocurrency. So here we have a block of information. So each block contains a number of different things. It contains data, it contains a hash of that data, and then also a hash of the previous block. Now, the data that that actual block contains will vary depending upon the type of blockchain that it is. If it's Bitcoin or cryptocurrency, it'll have a certain set of data. If it's used for supply chain or medical devices, or you name the industry, okay, there's different types of blockchains for different types of things. Each chain will contain different types of data, right? So it's not always the same. However, the hash and the hash of the previous block, that will remain regardless of the type of blockchain that we're talking about. So in this example, we have our blockchain, and we can see we have some data on that block, right? We have a hash of that block, and then a hash of the previous block. Now, since this is the very first block, there is no hash of the previous block. So that's referred to as a genesis block. Next, you can see the next block in that chain has a hash of the previous block, right? So that creates that linkage between the two blocks. It's going to have its own data and then a hash of that data. That hash then gets passed on to the next block and so on and so on, right? So that continues on for all blocks in that blockchain. Now, if for some reason we had a nefarious individual, right, a bad actor who goes and tries to manipulate or change the data on one of those blocks, it's then going to change the hash. That hash would then not match with the block on the subsequent block, and so on and so on. So those things immediately appear, and it would get rejected from the blockchain. The other thing to consider is the fact that blockchain is a distributed ledger, and so we have many, many people that make up this blockchain community, right? There's lots of people that have copies of the blockchain, and so they would need more than 50% consensus. In other words, a hacker would have to go in and manipulate all of those blockchains and all of those different people's computers and actually alter the hash and alter the hash of all the subsequent blocks across all the copies, or at least more than 50% of those copies, for that alteration to actually be accepted. Otherwise, it would be rejected from the blockchain. So that makes it a very, very secure and virtually tamper-resistant method of recording digital transactions and making everything very, very transparent.